Namaste and a very, very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about a very interesting topic, that is M-Estimators. Even before I proceed to demonstrate how to generate M-Estimators in SPSS, may I request you to subscribe to my channel, also like and share my videos. Let me begin by introducing the dataset to my audience. As you can see here, this dataset is called as car sales dataset. I have extracted this dataset from the samples folder that is present in SPSS. There are two columns in this dataset. The first is the model of the car, and the second is sales value of the vehicle. If you look at the first vehicle, it is Integra. The value of sales is 16.9. The sales value is expressed in thousands. When we speak about M-Estimators, one question that people usually ask me is, what are M-Estimators? M-Estimators are robust statistical methods used to reduce the influence of outliers. I repeat, M-Estimators are robust statistical methods which are used to reduce the influence of outliers. They address the limitations often encountered with OLS, or ordinary least squares regression. Now, when you talk about M-Estimators, M stands for MLE, or maximum likelihood estimators. M-Estimators are a class of robust statistical estimators designed to provide reliable parameter estimates in the presence of outliers. Unlike OLS, which minimizes the sum of squared residuals, M-Estimators use different robust loss functions to achieve this goal. These functions typically assign low weights to outliers. This is the secret behind the success of M-Estimators. They assign lower weightage to outliers, thereby reducing their impact on the estimation process. There are 5 important points that we need to keep in mind when we speak about M-Estimators. What are these 5 key points? The first is outlier sensitivity. Second is impact on parameter estimates. The third is loss functions which they use. The fourth is what are the applications of M-Estimators in practical scenarios. And last but not the least, the fifth key point is the trade-off between efficiency and robustness. Let's speak about each of these points in greater detail. The first is outlier sensitivity. This is one of the most important points about M-Estimators. OLS regression is highly sensitive to the presence of outliers. Let me repeat this point. Ordinary least squares regression is highly sensitive to outliers. It's a point which is worth mentioning again and again, that OLS regression is highly sensitive to the presence of outliers because it minimizes the sum of squared residuals, giving outliers disproportionate influence. In comparison to OLS estimates, the M-Estimators use robust loss functions that assign smaller weights to outliers, thereby reducing their impact on parameter estimates. Now, I said that M-Estimators use robust loss functions. What are some of the examples of M-Estimators? The most popular M-Estimator is the Huber's estimate. We then have Tukey's by weight. The second important point when we speak about M-estimators are their impact on parameter estimates. Outliers can significantly bias parameter estimates in OLS, leading to inaccurate models and predictions. This is where M-estimators come to our rescue. Why do I say this? M-estimators reduce the bias by downweighting or ignoring outliers in the estimation process, resulting in more robust and reliable parameter estimates. Let's now proceed to the third important point about M-estimators, which are nothing but the loss functions. While OLS minimizes the sum of squared residuals, M-estimators use alternative loss functions. Example, Huber's loss function or bi-square functions in Tukey's bi-weight that are less sensitive to extreme values. These functions adapt the weighting of the residuals based on their magnitude, making the estimator more robust. I repeat, the functions that we use under the M-estimators adapt the weighing of the residuals based on their magnitude, making the estimator more robust. The fourth important point. What are some of the applications of M-estimators in practical scenarios? In real-world applications, data sets often contain outliers. We all have seen that there are outliers in the data set. Why? The outliers come into picture because of measurement errors or unusual data points. Using M-estimators allow analysts to model data accurately without being overly influenced by these outliers, leading to more robust statistical inference. Let's now talk about the fifth point, that is the trade-off between efficiency and robustness. While M-estimators offer robustness against outliers, they may rather sacrifice some statistical efficiency compared to OLS under normal conditions. The choice between OLS estimators and M-estimators depend on the specific characteristics of the data and the importance of robustness versus efficiency in the analysis. To summarize, M-estimators provide a robust alternative to OLS regression by employing robust loss functions that reduce the impact of outliers on parameter estimation. If your data does not contain outliers, you can go ahead with OLS regression. On the other hand, if your data consists of outliers, it is advisable to use M-estimators. M-estimators particularly are valuable in those data sets where there are too many outliers and can significantly affect traditional regression techniques like OLS. Let us now proceed to generate M-estimators using SPSS. Even before we proceed to generate M-estimators, let's first investigate for the presence of outliers. One question is, how do we check for outliers in the data? There's a very simple graph which is called as the box plot, which helps us identify for the presence of outliers. To check for the presence of outliers, let me go to the Analyze menu bar. I'll move to Descriptive Statistics. Under the Descriptive Statistics section, the third option is Explore. Let me go ahead and select the explore option. Here, as you can see, I have selected sales in 1000 under the dependent list. In the first part, I'm just interested in the plot section. So I've made sure that I've selected only the plots. Let me now go ahead and hit the OK button. In the output, you can see there are a lot of interesting tables. You can see stem and leaf. Let me ignore all these things and go straight to the box plot. A box plot is a graphical display of 5 important statistics. What are these 5 important statistics? To explain what are these 5 important statistics, let me go ahead and double click on the box plot. Let me maximize this particular window. You can see here, this is the box plot, which tells me the distribution of sales in thousands. As you can see, there is a horizontal line here. This represents the minimum value. On the other side, what you're seeing is the maximum value. You can see a few asterisk mark here, case number 57. Now, this is an extreme value. You also see other cases like case number 53, 50, 41, 138, 58, 59, so on and so forth. All these points can be called as outliers. In summary, any observation beyond the maximum value can be called as outliers. So one conclusion that we can draw at this stage is that our data set has outliers. As we have already discussed in length, when we have outliers in the data, we cannot trust the results of OLS. What is the alternative? This is where M-Estimators come into picture. Let me close the box plot. Let's now proceed to generate some robust estimators in the form of M-estimation. To generate M-estimators, you need to go to the Analyze menu bar, come to Descriptive Statistics. Here, you've already seen the third option is Explore. Let me go ahead and select the Explore option. Earlier, I had selected plots. Now I'll be ignoring plots. I'll select only statistics. The moment you select statistics, at the upper right-hand side corner, the statistics tab becomes active. Let me go ahead and select the statistics option. Here, you can see by default, SPSS provides the descriptive statistics. And please make sure that you have selected the M-Estimators option. M, as I mentioned earlier, refers to MLE method or maximum likelihood estimation method. Once you select M-Estimators, SPSS generates 4 important types of M-Estimators. Please select this, hit the continue button, and then you can again hit the OK button. Here you can see SPSS generates different tables. The last of the options that you see is the M-Estimators table. As you can see here, SPSS gives us 4 different M-Estimators. The first is what is called as Huber's M-Estimator. This is very important. The second M-Estimator is Tukey's by-weight M-Estimator. The third is Hampel's M-Estimator. And the last one is Andrews Wave M-Estimator. SPSS reports the value under each of these statistics. It gives a description about the weighing constant that it has used in each of the M-Estimators. Let's go deeper into each of these M-Estimators. Let's first consider the Huber's M-Estimator. which reports a value of 33.94. Now, what is the Huber's M-Estimator? Simply put, Huber's M-Estimator is designed to be less sensitive to outliers than the OLS estimation. It uses a piecewise linear loss function that transitions from quadratic near the center of the data to linear in the tails. The weighing constant for Huber's M-Estimator is 1.339, which balances the trade-off between efficiency and robustness to outliers. Let's now proceed to talk about the second M-Estimator, which is called as Tukey's by weight. SPSS reports a value of 28.7. Question is, what is the Tukey's by weight estimator? Tukey's by weight is another M-Estimator that is highly robust against outliers. What is the loss function that the Tukey's by weight estimator uses? The answer is very simple. The Tukey's by weight uses a function that assigns 0 weights to the data points far from the median, thus heavily downweighing the outliers. I repeat, it uses a function that assigns 0 weight to the data points far from the median, thus heavily downgrading or downweighing the outliers. The weighing constant for Tukey's by weight is 4.685, which determines the shape and robustness of the estimator. Let's now proceed to talk about the Hampel's M-Estimator. The Hampel's M-Estimator is a family of M-Estimators that includes several tuning constants for different levels of outlier sensitivity. It typically involves a 3-part function that assigns different weights to data points based on their distance from the center, that is the median. The weighing constants provided are 1.7, 3.4, and 8.5, indicating different levels of robustness to outliers at each stage. Finally, what we have is the Andrews wave M-Estimator. Andrews wave is a variant of M-Estimator that applies a bi-square weight function to minimize the impact of outliers. It is similar in approach to Tukey's by weight, but may differ in the specific weight function used. The weighing constant for Andrews weight is 1.34 times pi, which influences the shape and robustness characteristics of the estimator. All in all, to summarize, M-Estimators like Huber's, Tukey's by weight, Hampel's, and Andrews wave are powerful tools in statistics for robust estimation, particularly in the presence of outliers, where traditional estimators may be biased. One question is, which one is the best and which one should you use? The choice of which M-Estimator to use depends on the specific characteristics of the data and the desired level of robustness. With this, I have come to the end of today's video. In today's video, we have seen what are M-Estimators and how are they more robust as compared to OLS estimates. We have also seen 4 different types of M-Estimators. I thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much once again. Have a great day ahead.